Hello everyone. In this video we're going to be solving for y in terms of x. We have a system 15 to the power x equals 45 and 75 to the power y equals 225. And we're going to be solving for y in terms of x. So I'll be presenting two methods, and let's start with the first one. For my first method, I'm going to use the rules of exponentials, and I'll break down everything into its prime factors. So 15 can be written as 3 times 5, so 15 to the power x can be written as 3 to the power x times 5 to the power x. And on the right hand side, we can write the 45 as 9 times 5, which is 3 to the second times 5 to the first power. You don't have to write the 5 to the first, you can just leave it as 5. So here, my goal is to put the 3's on the same side and the 5's on the other side. So let's go ahead and divide by 3 squared. When we divide two powers with the same base, we subtract the exponent. So we're supposed to subtract x minus 2. And we're going to divide 5 by 5 to the power x. So it's going to be 5 to the power 1 minus x. Great. From here, I can actually isolate the 5, or sort of like solve for 5, by raising both sides to the power 1 over 1 minus x. So in other words, it kind of looks like this. Take this to the power 1 over 1 minus x. Of course, x does not equal 1. We know that, right? Hopefully. And here, the same thing. And the motivation behind that is to get a 5 on the right-hand side, because these two are going to cancel out. Great. So from here, we get the following. 3 to the power x minus 2 divided by 1 minus x equals 5. Awesome. So we're going to do something similar with the other number, 75 to the power y. So 75 can be written as 3 times 25. So it's going to be 3 to the power y times 25 to the power y can be written as, okay, I'm going to write it like this first. Okay, no worries. And 225 can be written as 9 times 25, or 3 times 5 quantity squared. But anyways, let me write it as 9 times 25 first, and then I'm going to use the powers. So I can turn this into 3 to the y times 5 to the power 2y. This becomes 3 to the second, and this becomes 5 to the second. I just didn't want to skip that step. So here we're going to do the same thing. Let's put all the 3's on one side. So divide by 3 to the second, and right hand side divide by what is it called? 5 to the power 2y. So that becomes 5 to the power 2 minus 2y. And then we're going to be raising both sides to the power something so that we can isolate the 5. And that will be 1 over 2 minus 2y. And I know some folks are going to be like, why are you showing every single step? Because I want to make it understandable. Right? I don't want to skip steps so people are not left in the dark. So from here, 3 to the power y minus 2 over 2 minus 2y equals 5. Awesome. We got the 5 twice. That's cool. So now we can set these equal to each other. And remember, I want to write the y first because I'm solving for y. And I hope you know why. Okay. Now, since the exponents are equal, the bases also have to be equal, or if because the numbers are equal, bases are equal, so are the exponents. Okay, I kind of confused myself here. Anyways, so from here we can say that y minus 2 over 2 minus 2y equals x minus 2 divided by 1 minus x. And from here we're going to be solving for y, but solving for y is a little painful because of the way the x's are. So I'm going to go ahead and call this another variable. How about u? Okay. Now let's go ahead and forget about the x for now, and let's associate this directly with u. It's going to give us the following. If you do cross multiplication, y minus 2 equals 2u. Yay, this is what I was looking for. Happy birthday to you if it's your birthday. If it's not, don't worry about it. It's going to come up. So we cross multiply, and our goal here is, obviously, we have u in terms of y, so we want to solve for y. So let's bring the 2yu here and put the 2 on the right hand side, and then factor out y. 1 plus 2u, one more time, 2u plus 2, and then divide by 1 plus 2u, and that's going to give you y equals 2u plus 2 divided by 1 plus 2u. All right, great. Here, we're going to replace u with what it is, but this time we're going to use the x value because obviously we want to find y in terms of x. So let's go ahead and replace u with x minus 2 over 1 minus x. 2 times x minus 2 over 1 minus x plus 2 divided by 1 plus 2 times the same thing. And now we're going to simplify this, and now we'll get our answer. To simplify this, we need to make a common denominator. So kind of like 2x minus 4 plus 2 minus 2x over 1 minus x. And the bottom one is going to be 1 minus x plus 2x minus 4 over 1 minus x. 1 minus x is going to cancel out, so we can totally forget about it and focus on the new numerators and denominators. And it's going to give us 2x cancels out as well, so that's kind of nice. We get a negative 2, and at the bottom we get 3x. Nope, that's not 3x, that's just x. X minus 3. Awesome. Obviously, you can negate both the numerator and the denominator, and that looks like 2 over 3 minus x. So we don't have a negative sign in the numerator. It just looks a little better. So that is the answer, and let's go ahead and take a look at the second method. For my second method, I'm going to be using a slightly different approach, well, maybe a very different approach. I'm going to be using logarithms. So since 15 to the power x is 45, by using properties of logs, and you can look at the definition of logs. It's very simple. Even if you don't know any properties, just look at the definition if it's new to you, and you'll get it. It's pretty easy. So from here, x can be written as log 45 with base 15. And we can kind of simplify this by using, sorry about that, but I've got to use some properties. Change of base gives me log 45 over log 15. And now I can go ahead and break down the 45 into log 9 plus log 5. And then the bottom one can be written as log 3 plus log 5, because we have a rule, again, that governs all of these things. But I'll probably make a video on properties of logarithms because we use them a lot. Anyways, 9 can be written as 3 squared, so we can write this as 2 log 3 plus log 5. Again, these are in base 10. I just use base 10 and I don't write the base. So log doesn't mean ln here. So now, what can I do with this? Well, this is equal to x. So let's go ahead and cross multiply. 2 log 3 plus log 5 equals x log 3 plus x log 5. Now here, I'm going to try to find the ratio of log 3 to log 5. Let's go ahead and do that. So let's put all the log 3's on one side. 2 minus x log 3 by way of subtracting. And x minus 1 log 5 again by way of subtracting. And then since I'm trying to get the log 3 over log 5, let's divide by log 5. And oops, I was supposed to write log 3 here. Let's divide by log 5 and divide by 2 minus x. So we get the ratio in terms of x. Great. So that's one thing that I want to keep because I'll be doing it for the other number as well. But it's going to be very similar. So we have y equals, let me change the pen. How about blue? So y equals log, okay, I shouldn't write that because I want to start with the original one. Okay, so I had 75 to the power y equals 225. And then from here, y becomes log 225 with base 75. Okay. And then what am I going to do? Use the change of base. Sometimes I make mistakes, but I don't cut those parts because I just want to keep it very natural. Anyways, some people like it, some people don't like it. I hope you like it. So anyways, this is my thing, and I'm going to break it down just like before. 225 is, what was it? 25 times 9. It's going to be log 25 plus log 9. And 75 is 25 times 3. Okay, great. So I can write it like this. And then 25 is 5 squared and 9 is 3 squared. So I can use that. 2 log 5 plus log, oops, that's supposed to be log 9. So that is 2 log 3 over 2 log 5 plus log 3. And that's equal to y. And we're going to do the same thing. So we're going to get log 3 over log 5 from here. And we're going to set them equal to each other. I hope that makes sense. 2 log 5 plus 2 log 3 equals 2x. Oops. You see, I make many mistakes because I kind of rush. Okay, slow down. Take a deep breath. All right. 2y log 5 plus y log 3. Since I'm trying to get the log 3 on the left-hand side, let's subtract y log 3. 2 minus y log 3 is what I have. And on the other side, I have 2y minus 2. Notice that the same coefficients numbers are appearing because it's the same problem. So now, to get the log 3 over log 5, do the divisions, and you're going to get 2y minus 2 over 2 minus y. That is my other log 3 over log 5, but since they represent the same thing, I'm going to set them equal to each other. All right? So, and I'm trying to solve for y, so let's keep the y on the left-hand side, even though it doesn't matter, just for convenience sake. This is log 3 over log 5, and that is equal to x minus 1 over 2 minus x. X minus 1 over 2 minus x. So I should memorize it, right? At least I shouldn't forget it. Short-term memory. Now, we can do the same thing, call it u, so on and so forth. But I'm going to keep a long story short. You're going to get the same thing from here. Y is going to become 2 over 3 minus x. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.